Hi, welcome to Provoke Your Physics channel. Today we are going to discuss about the centripetal acceleration and the centripetal force. ரெண்ட பத்தியும் பார்ப்போம். Centripetal acceleration is an acceleration which is taking place in the circular motion. Circular motion is a typical motion. It is differ from the normal translational motion or linear motion. In a linear motion we can apply Newton's first law. Actually, what is Newton's first law? Unless the external force is acting on it, the object remains its position or a state. State means either rest or in motion. But in this case, in a circular motion, there won't be a rest. So the object has to be maintained the motion. And one more thing, in the linear motion we studied, when the object is in motion, okay, there should be an acceleration. If it is an acceleration, there should be a change in velocity or change in speed too. But in the circular motion, when there is a force, even though when the speed will be constant. Suppose when the object will be involving in a circular motion, that object can be rotated with constant speed. Even though if it is rotated with constant speed, it has an acceleration, it has a force. So that is centripetal force. அப்ப இங்க என்ன நடக்குது அப்படின்னா, ஸ்பீடு கான்ஸ்டன்டாவே இருந்தாலும் at every point the object changes its velocity. அப்போ இங்க வந்து ஸ்பீடுனா என்ன, வெலாசிட்டினா என்னன்னு நமக்கு தெரிஞ்சிருக்கணும். ஸ்பீடுனா என்ன? ஸ்பீடு வந்து the total distance by time. வெலாசிட்டி வந்து total displacement by time. அப்போ டிஸ்டன்ஸுக்கும் டிஸ்பிளேஸ்மெண்ட்டுக்கும் உள்ள டிஃபரன்ஸ் வந்து நம்ம ஏற்கனவே படிச்சிருப்போம். ஓகே, சிம்பிள். ஸ்பீடு வந்து ஸ்கேலார் குவான்டிட்டி, velocity வந்து vector quantity. So here the centripetal force and centripetal acceleration is a vector quantity. அது எப்படி நடக்குது, எந்த டைரக்ஷன்ல இருக்குது, அதை மட்டும் இன்னைக்கு கொஞ்சம் பார்ப்போம். So let us consider an object will be involving in a circular path னு வெச்சுக்குவோம். Okay, having O is an origin. Okay, so for my convenience I am just considering it is moving in an anti-clockwise direction. இந்த டைரக்ஷன்ல வந்து மூவ் பண்றதா நான் வெச்சுக்கிறேன். So now when I look at the position of the object at any point, for let us take this is A அப்படினு வெச்சுக்குவோம். இந்த இடத்துல எப்படி இருக்கும் இந்த ஆப்ஜெக்ட்? It is trying to move this side. இந்த இடத்துல it is trying to move this side. இந்த இடத்துல it is trying to move this side. Here this side. Here this side. Here this side. So if you notice one thing, at every point the object is trying to move along the tangential line, but it won't move. அப்ப எப்படி மூவ் ஆகுது? இங்க பாருங்களேன், இங்க இப்படி மூவ் ஆகுது, but something is pulling towards this side. இந்த டைரக்ஷன்ல அது தள்ளுது. ஓகே, அப்ப என்ன பண்ணும்? It is moving in a circular path. Circular pathல மூவ் ஆகிக்கிட்டே இருக்கும். And one more thing, see, when at every point it is trying to fall towards the center. It is trying to fall towards the center, but here in the tangential side it has one more force. Okay, it has a force, so it is moving along the tangential path too. Okay, so அப்ப அந்த ஏதோ ஒரு விஷயம் வந்து அங்க நடக்குது. இத நான் எப்படி பார்க்க போறோம் அப்படின்னா, let us take இந்த மாதிரி ஒரு ஆப்ஜெக்ட், ஒரு சர்க்குலர் பாத் எடுத்துக்குவோம். இங்க வந்து let us take this is an point A அப்படின்னு வச்சுக்கிறேன், and see this is point B அப்படின்னு வச்சுக்க போறேன். Okay, so initially it has a displacement vector R1 னு வச்சுக்குவோம் இத, and so this will be R2 அப்படின்னு சொல்லி வச்சுக்குவோம். Of course R1 is equal to R2 is equal to C, that is R. Okay, so here AB is the displacement னு சொல்லி சொல்லுவோம். Actually what is AB? Okay, that is making an angle theta. That is making an angle theta. Remember, okay, the theta is equal to arc by radius. In any circle, theta is an arc by radius. It is a ratio between arc by radius. So first theta is equal to arc by radius. Okay, now look at the radius vector. Okay, here the radius vector will be moving this side. Here the radius vector will be moving this side. But so here AB is nothing but delta R. What is delta R? Delta R is the difference of the vector. Difference of vector is nothing but the displacement. So here the displacement will be here. The displacement vector will be this side. About displacement, it is moving from A to B. The displacement vector is A to B. Right. Next, now I am just going to look out in which direction the velocity is acting. Okay, at A, the velocity will be acting this side. That is V1 vector. At B, the velocity will be acting this side. That is V2 vector. V2 vector. Okay. Now, so I have the 2 and 2 plus 2, 4 vectors are there. R1, R2, delta R. This is delta R. Adhe mari inga V1, V2. Okay. Now I am combining this one. Okay. In the triangle mattu thaniya eduthu paakren appadina. So this is R1 vector. And so this is R2 vector. Okay. And this will be delta R vector. Delta R is equal to R2 minus R1. According to vector formula, delta R is equal to R2 minus R1. What is its meaning? The difference of vector is equal to in magnitude R2 minus R1. Okay, and at the same time, so here theta is equal to according to the formula arc by radius delta R divided by any one of the radius. That let us take R1 and R1. Right. Now I am taking the V1 vector and the V2 vector separately. Okay. If I have taken V1 vector, what is the direction of V1 vector? This is the direction of V1 vector. What is the direction of V2 vector? This is the direction of V2 vector. Okay. Now, where the delta V vector will be there? Delta V vector will be in this way. See, this is V1 vector and this is V2 vector and this is delta V vector. Look here, and this point, in the point delta V vector, it is acting towards the center. It is acting toward, a change in velocity occur towards the center. Center நோக்கி தான் எனக்கு change in velocity நடக்குது அப்படிங்கிற விஷயத்தை நான் தெரிஞ்சுக்கிறேன். சரியா? Okay, so and one more thing, here the angle subtended by this 2 vector and this 2 vector is same. So even this theta and this theta will be the same. இந்த thetaவும் எனக்கு same அப்படினு என்னால சொல்ல முடியும். Okay, அப்படி இருந்துச்சுனா ஏற்கனவே நான் என்ன எழுதிருக்கேன், theta is equal to delta R by R1. Similarly I can take theta can be equal to delta V by V1. And of course, R1 is equal to R2 is equal to R. Similarly, V1 is equal to V2 is equal to V. Right. Now, what is our aim? To measure the centripetal acceleration. Acceleration I know that acceleration is nothing but change in velocity by time. Okay. So here, so let us take theta is equal to delta R by R, which is equal to delta V by V. Delta V by V. Okay. Right. Now, so when both are equal, now I am just taking this one. Delta V by V is equal to delta R by R. Okay. Now I am just taking delta V is equal to, this V will go that side, V by R into delta R. Now I am dividing on both sides with delta T. That is delta V by delta T is equal to V by R into delta T. What can we say this? See, delta R is nothing but the displacement. Okay. So displacement by time is nothing but velocity. Okay. So I can have this. Okay. This will be equal to delta V by delta T is equal to V by R into V. V by R into V. Now delta V by delta T is nothing but an acceleration. So A, which is equal to V squared by R. Okay. What is this? This is the centripetal acceleration. Now I am applying Newton's second law. What is Newton's second law? F is equal to m times of A. Suppose if the object is having the mass m, means the centripetal force F is equal to m into A, which is equal to m into V squared by R. Okay, this is centripetal force. So now you may know that the centripetal force which make the object to be move along the circular path, first point. Second one is it is always trying to pull towards the center. Pull towards the center. Okay, that is, it is so called centripetal force. Thank you.